Okay, good morning. Welcome back to Calculus 2. So here we have the summation from n goes from 1 to infinity of 2n factorial over n to the 2n. All right, now we have to test for convergence. Now, on one side, I would say, the root test might not be too bad because, look, we've got an n to the 2n up here. But as soon as you see this factorial, it almost screams at you, use the ratio test, okay? So what we're going to do is, again, we're going to see what happens to the absolute value of a to the n over, or a to the n plus 1 over a to the n. And we're going to take this limit as n goes to infinity, and then we're going to evaluate, we're going to go ahead and do all the algebra we need to do on this. Then we're going to apply our limit and see what happens, okay? So we're going to go ahead and set this thing up. I'm going to drop the absolute values because I know that these guys are positive, but when we make our conclusion, again, if my limit, which I'm going to call L, is greater than 1, then we could say diverges. If my limit is equal to 1, then we have inconclusive results and we have to do something else. Or we have the limit is less than 1, it converges, but because the theorem, because the test is the absolute value, we have to say converges absolutely. Okay, because that's what the test is dealing with. But it's always positive. It doesn't matter. That's what we have to deal with because the absolute values are inside the test, so it's implicit into that. Okay, so first thing we're going to do is we are going to go ahead and apply our n plus 1. So we have 2 n plus 1, and this whole thing is inside of a factorial, okay? Divided by n plus 1 raised to the 2 n plus 1, okay? Everywhere I see an n, I'm going to replace it with an n plus 1. And then we're going to divide this by 2n factorial over n to the 2n. Okay. Now that's the first little bit out of the way. That's just the setup. Okay. Now we have to start applying what goes on here. So we're going to say this is going to be 2n plus 2. We just multiplied the two n's by this piece here. We are still inside of a factorial. Okay. Over on the other side here, we have n plus 1 raised to the 2n plus 2. So again, we're going to use our rules of exponents, and then this is divided by, okay, so we're going to be divided by 2n factorial divided by n to the 2n here. Okay, just hang on to this piece. We're not ready to deal with it just yet. What I'm going to do is I'm looking forward. I'm saying, hey, wait a minute. There's going to be a 2n factorial here. So I need to turn this back into a 2n factorial if I can. And I need to turn this thing into an n to the 2n if I can, or something like something raised to the 2n, because this plus 2 is not helping me. Okay, so what I'm going to do is say, okay, 2n plus 2 factorial, that's equal to 2n plus 2 times 2n plus 1 times 2n factorial. Okay, because factorial just says you take that number minus one more, dot, 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 until you get that to something that's convenient. So we're just going to have this piece here. And then we're going to say that we have, this is going to be n plus 1 squared times n plus 1 raised to the 2n. That's just going through and dealing with the rules of exponents. And then on the bottom, we have a 2n factorial and n to the 2n up here. Okay. Now I think I'm ready to go invert and multiply in order to get rid of this complex fraction, because this is something kind of scary here. So we have a n to the 2n up here divided by a 2n factorial. Okay. Here we have an n to the 2n up here. We have a 2n factorial here. Okay. The whole point of the inverting and multiplying is it gets rid of the complex fraction. So thank goodness for that. These two, okay, this 2n factorial, this is going to cancel with this piece up here. So let's see what we have left here. So we have, let's take an inventory. So we have a 2n plus 2, 2n plus 1, 2n plus 2, 2n plus 1. Okay, what else do we have up there? That's all we have, times an n to the 2n, n to the 2n. And we're going to be divided by, and here we have an, what do we have here? We have an n plus 1 squared, n plus 1 squared, and we have an n plus 1 raised to the 2n. Now, I can't do anything by pushing this thing inside. I'm just kind of stuck with what we have at this point. But that's kind of all the algebra I can deal with as far as the ratio test goes. I'm getting prepared to take my limit. Okay, and one of the things about limits, you go back to remember your your calculus one rules is limits are really, really forgiving. Like we're going to apply a limit here, then a limit here, then a limit down here, then a limit to the exponent. Like you could separate these things out a lot to take your limits. Okay, the limits work that way, and that's kind of nice. So what I'm going to do is I'm going to kind of like let's kind of segregate the polynomial stuff from the exponent stuff just so I can see what's going on here. So we're just going to multiply this piece out here. So I still have my limit as n goes to infinity. Here we have a 4n squared. We have 2 plus 4. That's going to give us 6n's plus 2 divided by n squared plus 2n plus 1. And then here we're going to say this is going to be n over n plus 1 all raised to the 2n. Okay, we're going to take this guy apart a little bit too. How are you going to do that? Like, I'll show you how we're going to do that. So we're going to use a lot of rules of exponents with this piece here. Okay, so we have our limit as n goes off to infinity. Here we have our 4n squared plus 6n plus 2 divided by n squared plus 2n plus 1. This part doesn't really seem quite so scary. Okay, now over here, we're going to have n over n plus 1. I don't know what this is, but I know that, how about this one? How about n plus 1 over n raised to the n? Right, that's 1 over 1 over n raised to, hey, that reminds me of a special number. That reminds me of e. Okay, so this isn't exactly the form I want. I would like the reciprocal of this. Fortunately, reciprocals are kind of easy to deal with as far as exponents goes. So I'm going to say this is going to be n plus 1 over n raised to the negative 1 raised to the n, okay? And then we'll go ahead and say, how's this going to work? Actually, I want, yeah, raised, and then this whole thing squared, okay? The way that this thing works, the way you're supposed to do your parentheses, you order your parentheses is that's your first order. If you need more parentheses, you put a square brackets. You need more, you put curly brackets, and that's like the order of like how you're supposed to group your parentheses. Most people just use parentheses or just use brackets. It's fine, but if you wanted to be absolutely proper about it, you would say parentheses, then brackets, then braces. And that's how you would do that. Okay, so here's what we have for this thing. So I'm going to say we have 1 plus 1 over n raised to the n is e, but if I put a negative in here, that's going to be 1 over e. So it's going to be e to the negative 1. Okay, so here we haven't done anything with the polynomial yet. So we have 4n squared plus 6n plus 2, all divided by n squared plus 2n plus 1 times. Now, this little piece in here, this is going to be 1 over e. That's this part here, negative 1 times n here. Okay, to swap the order for them, that's okay. But then we also squared it. Okay, so we still have a squared here. So we are looking at 4n squared plus 6n plus 2 over n squared plus 2n plus 1. I'm just going to multiply by 1 over n squared on top and bottom here. Okay, so we're going to say this is going to be 4 plus 6 over n plus 2 over n squared, okay, divided by n plus 2 over n plus 1 over n squared, okay? I'm taking my limit now, okay? And here we have an e to the negative 2 sitting here. That was this whole business over on this side, trying to figure out what was going on with this whole exponential thing going on. And that was a little bit tricky, but I think we got through that to say, okay, that's e to the negative 2. So as I go through this limit here, I know this piece equals 0, this piece equals 0, this piece equals 0, this piece equals 0. So we have 4. So my whole limit here, this is going to be equal to 4. This is just 1. It's not 1. This is 4 times e to the negative 2. That's my whole limit here. Yay, we've calculated our limit. So we have 4 over e squared. Is my limit less than 1? Is my limit equal to 1? Is my limit greater than 1? Or is it too hard to tell? Well, e squared is, I know e is about 3, so I'm going to say this is probably 4/9, more than 1. So a bit less than 4/9, but still, like at worst, it's going to be 4/8, it's going to be half. Okay, so we are less than 1. So I can say that this series converges Okay, so we have, what was it? It was 2n factorial over n to the 2n converges to 4 over e squared by converges absolutely by the ratio test. Okay, and that's how I would go ahead and answer that question. Okay, so I know that one is a little bit long, but we're really gonna use we're really gonna work the limit rules here in order to kind of deal with the parts of the limits that we can deal with, and then we're gonna kind of closely examine the parts of the limits that are like, well, this is a little bit more complicated. So 1 + 1 over n raised to the n, that's a as n goes off to infinity, that's a good limit to know for everything because that comes up over and over and over again. And I will never forget like sitting in I don't know, one of the upper physics classes, and we ended up with like a whole thing. And yeah, he was writing it out. I was like, oh, that's E. I was like, how did you know that? I'm like, oh, because I'm actually a math major. I know what these things look like. But it was very nice to, be able to recognize this on site and kind of be one of the few people in the class who was like, got you on that one. So that was, that's an important one to remember. But it's kind of a tough problem, but just like with the limits where we kind of take everything apart and look at it one little thing at a time. That's kind of what you're doing with this piece here. So we applied the ratio test. We dealt with the algebra with the a to the n plus ones, a to the n plus ones over a's. We took all of those apart and strung those out to like group the stuff that was easy to deal with the stuff that was easy to deal with. Easy, using quotation marks. And so we could actually evaluate what was going on. Okay, so that's kind of a way around that problem. I say thank you very much for watching the video. I'll see you in the next one. Take care until then.